and hopefully you'll get a reaction sheet. But this is called the haloform reaction. And what does it do? Um, so we know that the alpha carbon has alpha hydrogens that are acidic. Okay, so um, in base, we're just going to do these reactions in base, like sodium hydroxide, it's your typical base here. You can form the enolate, right? And this is the mechanism. In the haloform reaction, your electrophile then is it's some kind of halogen. So it can be Cl2, Br2, or iodide 2. Okay, and so what happens here? Let's look at a reaction. You have like a ketone, and you react it with chlorine and sodium hydroxide. Now you always find your alpha carbon. You write in your alpha halogens, and then the sodium hydroxide will deprotonate to make your enolate. Okay, that's step one. Form enolate. And then your chlorine, your halogens, can be polarized to make one positive and the other one negative. And so then these electrons will go after the positive. This is your electrophile. This is your nucleophile. And then those electrons leave, and you get the chlorine added to your alpha carbon. Okay, so you know this mechanism. Now, this is base promoted rather than base catalyzed. So what does that mean? Catalyst means you can put probably 10% equivalence. Okay, so for every 1 mole of ketone, you can do 0.01 mole of base. But that's if it's catalyzed. If it's base promoted, for every one equivalent, so for every 1 mole of ketone, you have to have one equivalent, 1 mole equal molar of base. Okay? So now, the haloform is really about the methyl. You see it really in methyl ketones. Okay? So we're going to show you what a methyl ketone is. That's your substrate. So if I were you and I was filling out my reaction sheet for the haloform reaction, I would say my starting material are I would say that they are methyl ketones. Here's my starting material. And my reagents are sodium hydroxide and a halogen. And then your product is going to be a carboxylic acid. So it's going to be a carboxylic acid plus a haloform. Now what's a haloform? Okay, well CHCl3 is called chloroform. CHBr3 is bromoform. What do you think CHI3 is? Iodoform. Okay, so that's the haloforms. Now, if you read your water bill, if you live in eastern Kentucky, your water bill produces these haloforms. And they say that they're toxic. And so read your water bill next time, okay? And they have certain levels and they're toxic and it's in your water. We had a nice chemistry seminar that talked about these haloforms in our water, and I wasn't even aware. And what's happening is when you have organic matter that have a methyl ketone. So here's a ketone, and here's a methyl. So I'll just write CH3. Okay, so that's a methyl ketone. And you treat it with disinfectants like bleach, Cl, and base, you're going to get, so this is 2-pentanone, and this is your product. Butanoic acid plus CHCl3, chloroform. And that's all your 5 carbons. So let's look at that mechanism. And this is the mechanism I would get in your notes. Okay, so sodium hydroxide, and we're going to use bromine. Okay, first thing, find your alpha carbon, write in your hydrogens, draw your enolate. There's my monkey face. Then put in your Br, delta positive, delta minus. Those electrons go there. So now you have Br there, and that carbon. Now this is the key. This product, the alpha hydrogen, is more acidic than the starting material, the methyl ketone. And why would that be? Because the bromine is electron withdrawing group. Remember, your halogens are electron withdrawing. Okay, so this makes these other two hydrogens more acidic. So you still got sodium hydroxide. All right, so now we're going to form an enolate again. This time we have Br there, and we have our enolate. Okay, and we still have Br. And so those electrons will go here, and we'll make Br blue here. Br, Br, and we still have a hydrogen. We still have one alpha hydrogen. This is even more acidic than the previous one, this hydrogen. So we still have base. So we still have sodium hydroxide. And let's take away all right. There's your enolate, and you still have bromine. And now you have 3 bromines. Okay? Now, this here is an excellent leading group. And you have a strong nucleophile. Okay? So, and you have your electrophile here, the delta positive on that carbon. So here, those electrons will go here. You did this the first week of school in Organic 2. You made your tetrahedral intermediate. We make a tetrahedral intermediate. I expect you to be able to write this mechanism. And there's your OH. OH. Okay, so that's your tetrahedral intermediate. We'll write that down. Tetrahedral intermediate. And then what happens? You want to reform the carbonyl, and the CBr3 is going to be your leaving group. So let's reform our carbonyl. Those electrons will go here, and then these electrons leave. So what does that look like? OH, then you have C, Br, 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 okay, and then this will take away that hydrogen, and you will form the chloroform. And this is the bromoform, right, to be exact. There's your hydrogen, and then what you do is you put it in the separatory funnel, and then you would get this protonated. Okay, so and that gives you your carboxylic acid. And that is the mechanism of the haloform reaction. So it is a ketone base promoted alpha carbon is completely halogenated. Methyl I'll just write the little summary here. So the ketone, the methyl ketone, it's base promoted. Base promoted alpha carbon atom is completely halogenated. Methyl ketones have 3 alpha protons. They undergo halogenation to give trihalogenated ketones. And then the base will attack the trihalogenated ketone, which is your leaving group, to form a carboxylic acid. Okay, so just to reiterate this, we'll do it with an R group, an ER. Here's your methyl ketone, okay? You would basically have this in base, and you would have excess, and you would have excess, let's say chlorine. This would form, if you didn't have to draw the reaction mechanism, that's the product of that. And then this would undergo the sodium hydroxide. This could come here, this would go up, and then that would leave, and you would form CHCl3, and then this would get protonated to form your carboxylic acid and your haloform. Like I said, look at your water bill and you would see that. I don't think I have any questions for you to work, so I'm going to add one. Okay, so your Pogo exercise that you can add here. So let's draw the product and reaction mechanism for the following reaction. And let's do excess sodium hydroxide and excess iodide. Okay, so draw the product for this reaction and the reaction mechanism.